Why is C++ cross-platform compatibility hard for robotics? Imagine building a robot that can work anywhere in the world, but every time you try to run your code, it refuses to cooperate. That's because making C++ work smoothly across different robotic systems isn't as simple as it sounds. C++ is popular in robotics because it's fast and flexible, but that same flexibility can cause headaches when trying to make code run on various hardware and software setups. Robotics platforms are like snowflakes. Each one has different processors, sensors, and motors. Some robots use ARM processors, others use Intel chips. Sensors like cameras, lidars, and ultrasonic sensors all have unique interfaces. Writing C++ code that talks directly to these hardware parts means you often need to change or rewrite parts of your code for each robot. What works on one might not work on another because the low-level drivers are different. Then there are the operating systems. Robots can run on Linux, real-time operating systems, or Windows. Each system has its own way of handling system calls, libraries, and memory management. C++ programs might depend on certain libraries or features that are only available on specific systems. This means you need to write conditional code or use abstraction layers to hide these differences, which adds complexity. Handling real-time tasks and multi-threading is another challenge. Robots often need to do many things at once, like moving a joint while processing sensor data. Different platforms handle multi-threading differently, making it tricky to keep timing consistent. If your code relies on specific timing or synchronization, it might work perfectly on one system but fail on another. Frameworks like Robot Operating System are designed to help, but they also have their own cross-platform hurdles. Moving code from one version of Robot Operating System to another or from Linux to Windows involves changing build systems, middleware, and APIs. This impacts how C++ code interacts with hardware and software components. Hardware differences also mean you need to create layers that translate generic commands into platform-specific instructions. For example, controlling a robotic arm with different joint configurations or sensor setups requires extra code to adapt. This makes maintaining a single code base that works everywhere a big task. In the end, making C++ code work seamlessly across various robotic systems requires a lot of planning. You need to design modular, adaptable code that can handle different hardware, operating systems, and software frameworks. While C++ is capable of cross-platform development, the diversity in robotics hardware and software ecosystems makes it a complex challenge.